Hi there, welcome to your review of factoring and some applied problems. To begin, have your factoring reference sheet nearby. We have filled in most of the main factoring techniques here, except for the last one. So let's recap the ones we've seen and then fill in the last one to begin. So this, I'm not going to pause here. You can pause if you need it, but we've looked at this. First thing you always do in factoring, take out the GCF. Next, we looked at a special two-term polynomial. So whenever you see a two-term polynomial like these, there's two terms, always think it might be a difference of squares. It won't always be one, but it might be. And if it's a difference of squares, it can be factored like this. Next, we looked at three-term polynomials. So 1, 2, 3 terms. And these are often called quadratic trinomials. And we looked at a method called x factor to factor those. So review that method here as well. And then we also looked at GCF combined with quadratic trinomials, right? You should always look for GCF first, which is what we did here, and then you're left with a trinomial that can be factored using that technique. Then we looked at the cases where the a value, the first coefficient, the coefficient in front of x squared, is not 1. When that is not 1, we begin with x factor, but then we do a longer technique called grouping, and we can see the grouping technique here. So these two numbers, whereas before they led to the factors, now they lead to the expansion of the middle term and then grouping to factor it completely. All right, then we had a special pattern for three-term polynomials, which are called perfect square trinomials. They look like this. This one factors like that. So when you see 2 times these two values in the middle, it's always going to factor like this, perfect square. And when you see a minus sign there and the same pattern there, it's that. So these two examples, let's take a look. This one is definitely a perfect square because the square root of this is x. The square root of this is 7. And in the middle, I can see 2 times 7 times x. So I rewrote it like this. Here's something squared, here's something squared, and in the middle, we have 2 times those two pieces. So whenever it takes that form, it's a perfect square, and it factors very simply into x plus 7 squared. Let's look at the negative example. We have a negative here. Let's see if it's a perfect square first of all. Is this something squared? Yes, it is x squared. Is this something squared? Yes, it is 12 squared. Then we check the middle term. Is the middle term 2 times these two? It is 2 times those two. So now we can rewrite this in this factored form, x minus 12 squared. Great. In class or recently, we're looking at all these factoring problems, and there's a lot of kind of challenging applied problems here. So let's take a look at some of the more challenging ones together. I will show all the answers, but I'll pause and talk about the ones that take a little more thinking probably. So we began here with problem solving. We're filling in the blanks. These first two should be pretty straightforward. I hope you got those. Check your work. Then B and D also should have been pretty straightforward. So there's the answers for those. This one may have been a little tricky because they put a plus sign here, but for this difference of squares to work, we need it to be a minus. So we can put plus -2. That works. Okay, E and F were a little different. They took a little more thinking to figure these out. So this might make you think right away it's a difference of squares, but you can see there's a 5 and a 20 here, so it's not a difference of squares. So difference of squares is not the only polynomials that don't have that middle term. The middle term can cancel in other ways as well. So let's take a look. What do we know for sure here? Well, we know 5 times -20 is going to give us -100. So we know that value for sure. And then we know, okay, so question mark t squared minus 100 equals this. If I expand this, I have 3t times this question mark t. And then I have 3t times -20, which is this. And then I have 5 times this question mark t. And then I have 5 times the -20 is there. So here's the two middle terms, the two t things, right? This is going to be our t squared. This is just our constant. And this is going to be our two t pieces. But since in the final form here, we have the squared, we have the constant, but we don't have the middle t term, that means these two must cancel. So -60, and this must be +60. So we know if this is +60, those will cancel. So 5 times what? Well, 5 times 12. So that tells us this must be 12. And in that case, we know this is 12t. We know these two are that. So the middle two, again, -60, +60, those will cancel. This becomes 36t squared, and there we have that 100 there. So now we know this is 36. Pause if you need to take a closer look at that. That's a good kind of application of the idea of factoring and also multiplying, expanding binomials. Make sure you see all the reasoning that went into that. Let's try the same approach here. In this case, we know this is 18 because 3 times 6 here in the beginning, we have to have 18x squared. So I'm going to write that as well. So 18x squared minus something equals this. When it's expanded, we have 18x squared. We have two middle terms, 3x times something, 4 times 6x here, and then 4 times something here. In this case, we know the two middle terms, again, they will cancel, right? Because there's no middle x term. So these will cancel. This makes 24. So that means this 3 times something here must make negative 24. So that tells us right away that must be a value of 8. And now that we know that's 8, we can multiply those out. These will cancel, we can confirm, and we have the 32 that goes in the end here. So again, pause if you need to, take a closer look. Good reasoning problem. Next, there's some more here. These ones I'm just going to put the answers. These were pretty straightforward. Check your work that you've done. Okay, nothing to explain there. If you know basic factoring and expansion, these should be okay. So check your work. Okay, then we got into rectangular areas. These started pretty basic. When we have the area of a rectangle or square, we just multiply base times height, right? We multiply length times width or base times height. So this times this will give you this area. And these two multiplied, well, you got to figure out what this one is. So we can factor this one, this quadratic. This quadratic factors into this. Therefore, we know that the question mark must be x plus 5. Same thing here. Check your work. Okay, next one. This one was definitely a lot more challenging. I love this problem. All right, it tells you the perimeter of this rectangle is this. So I'm going to start with that actually. I know that perimeter is equal to 2 times this side plus 2 times the other side. Okay, so that's the perimeter. 2 times this plus 2 times this. Now I'm going to expand this a little bit. So multiply through the 2 here, multiply it through here. Simplify it some more. 2x plus 2x makes 4x. We have minus 2a minus 2b here. And notice we have 4x on both sides, so we can cancel that, subtract it from both sides, and we're left with this. And now I see a negative 28, negative 2, negative 2. I'm going to divide everything by negative 2 to simplify this. So negative 28 divided by negative 2 is 14, and then the negative 2's cancel here. So I've found out that 14 equals a plus b. So a plus b must be 14. Okay, so now let's move forward. We also know the area is this. Area is this. And again, we know if we multiply the two sides, we'll have the area. So that's what I'm going to do next. I'm going to multiply that by that, and that multiplies into this. Okay, it's okay if we have the b and a there. So x squared, and then negative ax, negative bx, and then plus ab, because those two negatives multiply and make a positive. That can simplify into this. I took the middle part here, and I factored out an x. So a plus b, and then there's a negative x there. That's a interesting approach to factoring there. So take a look at that. And now we know the middle term is a plus b, and this is a times b. Well, we know that. That's the rule for multiplying or expanding binomials like this. We're going to get the addition of those two things in the middle and the multiplication of them at the end, the product and the sum, right? So now we know, but we do know that the sum is 14. So we know this number is 14. So what two numbers add up to 14 and then multiply to this AB, which is 24? Well, those two numbers, well, again, so there's the 24 from the end here. Here's the 14 we know for a plus b. So we're thinking of two numbers that multiply to this but add up to this. And those two numbers are negative 12 and negative 2, because negative 12 times negative 2 makes 24, and you add those to get to negative 14 here. So that's how we are able to figure out what these two side lengths are in this rectangle. Great problem. All right, these ones a little bit tricky as well. It says use the x factor method to figure out all the possibilities for the middle term here. So check it out. I wrote this like this. I'm going to call that blank an a. Okay, it's an unknown value. We're going to call it a. Then I'm going to use x factor. X factor tells us we're going to do 3 times 2 first here, and then the b value goes on the bottom. Now we're thinking of two numbers that multiply to 6 but add to a. Well, a is not a number, so what multiplies to 6? Well, 1 times 6 makes 6, and then if you did 1 times 6 here, you do 1 plus 6 makes a, so a must be 7. What's another combination? Well, -1 and -6. So if you had -1, -6 here, those multiply to 6. But when you add them, they make -7. So A could also be -7. What's another combo? 2 and 3. All right, so this is 2 and 3. They multiply, and then they add to 5. So A could be 5. And finally, -2, -3 gives you that one. So pause there if you need to. Really great problem. Good reasoning as well on that one. Look at B. In B, we have this expression, or this quadratic. I'm going to call this A now. Again, let's use the X factor method. 2 times A here, 9 on the bottom. Okay, now what two numbers add up to 9? Because here is an unknown. So what numbers add up to 9? Well, 1 plus 8 makes 9. Therefore, 1 times 8 has to be 2A. See, 2A equals 8, because 1 times 8. And that means A equals 4. Let's try another one. What other numbers add up to 9? Well, 2 plus 7 make 9. 2 plus 7 adds up to 9. And therefore, 2 times 7, which is 14, equals 2A. And that means A equals this. Try another one. Can you think of another one? Definitely. There's that one. Check that one. And there's also this one. I think I've listed all the possibilities. Great, great problem. Okay, try the same approach in C. And how many possibilities are there for that space there at the end? And now check your work in C. In this case, let me show you something here. All right, 6A on top, 10 here. So you're adding two numbers to make 10. 1 plus 9 makes 9. But then 1 times 9 equals 6A. And that does not give you a whole number. No good. Numbers add up to 10. 2 plus 8. 2 plus 8 makes 10. And if you multiply 2 plus 8, sorry, 2 and 8, it makes 16. So 16 must be equal to 6A. Again, that does not give us a whole number. The only time this works out is with 4 and 6. So we've had 4 plus 6 makes 10. 4 times 6 makes 24. And 24 equals 6A. That you can divide, and you get A equals 4. Otherwise, it's all going to be decimal values. Okay, next, we have this problem. It says you have two grids, and on these grids, you can lay these cubes. Okay, so it's just an area problem with a volume component, but the volume part's not that important, because there are 1 by 1 cubes. So that we're trying to find that area, which is this, multiply that to get this. Then we find the area of the blue rectangle here, or square, I guess, because it's n plus 3 squared. That becomes that. Then it says simplify by combining the two grids. So if you combine those two areas, you're just going to add this one and this one, right? This represents an area, so does this. So we add them, we get a total area of this. Check your work. And now finally it says show that if you took the grids apart and put them together again into some new rectangle, the cubes could fit on it perfectly. Well, if this can be factored, then we know that this makes a large rectangle. And I'm trying to factor that. I have 30 there, 2 times 15, 13 here. The numbers are 10 and 3. Therefore, I'm going to do grouping because A is not 1. Factor by grouping, follow the steps, and I get this. And since that was able to be factored, it means that these combined can make some large rectangle because we have a product of sides here. So it works out. Next one, this one here, tells us there's this thing. Read the problem carefully. There's a pitch and a border area, but the area of the whole thing is this number here. So I'm going to take the whole area. I'm going to factor it. So I have 180 there, 4 times 45. I have this number. I have those. And finally, I'm factoring it by grouping, expanding like that, grouping, grouping. I factored it. So I found out that the dimensions of the whole thing are 2n plus 9 times 2n plus 5. So if this is 2n plus 9, and we see an n distance here and n distance here, that's already 2n. That means this must be 9, because now the entire length is 2n plus 9. And likewise, this must be 5, because I have n here, that's 2n plus 5, and that's that whole length there. Another great problem. All right, this one I saw a lot of students do really well with it. I'm just going to show the answer here. All right, and the main thing to note here is that when this is the number she said, if this is the words taken into this, expand that, factor that, we get this simplified, factor that, and then we have a product. And that's what it's saying here, show that it can be a product. Well, we've shown that her number can be a product, and the product has a difference of 6, because the difference between these two numbers is 6. We've shown it here. We subtracted them and it's shown the difference is 6. And then there's another one just like that. Pick the work here. Another good problem. Read that carefully. Really, really good problem. The thing about evens and odds here is really important. Know that an odd number is 2n plus 1 or 2n minus 1. And finally, there's these ones. Practice these to be prepared for our assessment next week.